So one of the things with this division algorithm that we're going to focus on is dividing polynomials by linear polynomials. So dividing by polynomials of the form x minus a. And so not only is it linear, meaning there's no squared term, no cubed term, it's just x to the first power. It's a degree 1 polynomial. But also monic. So monic, just as a side note, monic means the leading coefficient is 1. And by leading coefficient, what I mean is the coefficient of the highest power term. Okay. And so a monic polynomial is always 1 times whatever the x to the degree of the polynomial. All right, so we're going to be dividing polynomials by polynomials that are linear and monic. So they're of the form x minus a. So when we do that with the division algorithm, we have given any f of x. If we're going to divide minus a, we know we can write f of x as q of x times x minus a plus r of x, where r of x, the degree, is greater than or equal to 0, but less than the degree of x minus a, which is 1. And so the degree of r of x, and I should write, or r of x is the 0 polynomial. So the degree of r of x is 0, because it has to be greater than or equal to 0, but less than 1, or r of x is equal to 0. In either case, r of x is a degree 0 polynomial or it's the 0 polynomial. And so in either case, let me write that down. In either case, r of x is a constant polynomial for some k in r. It's a degree 0 or it's the 0 polynomial, so it's a constant polynomial no matter what. So what we want to think about for a minute is, what is that constant k? So we're going to do 2 short examples just to see what happens with this. So we're going to take f of x as x squared minus 3x plus 1, and our a is going to be 2. And so I want to write f of x, that x squared minus 3x plus 1, as something times x minus 2 plus whatever my k constant is for my remainder. And I'll let you try this on your own. I'm just going to fill in the answer, and you should verify that this works. So what our quotient is going to be is x minus 1, and we're going to have a remainder of negative 1. Okay, so our r of x is negative 1. And the one thing I want to point out here is that if you plugged a equals 2 into f, what you would get is 4 minus 3 plus 1. Nope, 4 minus 6 plus 1. I knew that wasn't working. And so you will get out of that a negative 1. Okay, so the r happens to be the same as f of 2. Let's try one more example that's really similar just to see that this works in another case also. So if f of x is x squared minus 5x plus 6, and again a is 2, then this time when I try to use this division algorithm, I take x squared minus 5x plus 6, and I want to write it as something times x minus 2, because my a is 2, plus some remainder. This time it factors evenly, so what I get is x minus 3 and a remainder of 0. So my r of x in this case is 0, and if you tried plugging f of 2, if you try plugging 2 into f, you get that f of 2 is 0. And so again, we get this matching thing. Turns out that this is a lemma that we're going to be able to prove pretty easily. So the lemma says if you have a field and f is a polynomial over that field, and a is any element in the field. The remainder after dividing f of x by x minus a is f of a. Okay, so we're gonna try to prove this, and it's not a bad proof. So we're gonna use the division algorithm. So by the division algorithm, we can write f is q of x times x minus a plus r of x. And we know r of x is a constant for some k. And we're mostly talking about r of x as a constant in R, but I'm going to use f for the field because that's how the limit is written. It's written in general, not just for R. All right, so plugging a in. So we're going to plug a into this equation. What we get is that f of a is equal to q of a times a minus a plus r of a. So f of a equals r of a. Okay, but r of a is just equal to r of x because r of x is a constant, and so whatever it is when you plug in a, that's what it is when you plug in no matter what. So the remainder function, r of x, is just equal to f of a for all x. Okay, so that's the whole proof. What we showed is that there's an easy way to figure out what that remainder is when you're dividing by a polynomial of the form x minus a. You just plug a into the function.